Hello everyone, I welcome you all to my YouTube channel. So this is the part 2 of the question series of Class 10 Maths Polynomials chapter. So let's begin. The first question is the polynomial which when divided by this polynomial gives a quotient of x minus 2 and remainder 3. So the solution is very simple. We'll use division algorithm. You must be knowing dividend is equal to divisor into quotient plus remainder. Divisor is this. Quotient is x minus 2 and remainder is 3. Just put these values in this formula and you'll get the dividend, which is the required polynomial, right? So substitute like this, and on simplifying you will get this is the answer. This is just a simple multiplication. You can solve it very easily. First multiply x with this entire bracket, then minus 2 with this entire bracket, and in the answer finally add 3, right? You'll get this polynomial. So the second question, without wasting any time, what should be subtracted from the polynomial so that x equal to 15 is the zero of the resulting polynomial? Uh, let's read again. What should be subtracted from this polynomial? इस polynomial में से क्या subtract करें so that x equal to 15 is the root of this polynomial, right? So let us represent this polynomial by fx. So I'm finding f of 15, and on putting x equal to 15 here I get f of 15 on simplifying this equal to 15, right? So अगर 15 0 होती इस पॉलिनोमियल की तो f of 15 0 होता, right? But this is not the case. F of 15 is not 0 here, so 15 is currently not the root of this polynomial. So if x equal to 15 is the root of this polynomial, then f of 15 will be 0. So subtract what needs to be subtracted, right? So let's move to the next slide. So if 15 was the 0, as I told you, f of 15 would be 0. But we are getting f of 15 equal to r, so we'll subtract this quantity, which will be the output, right? So suppose that for any general point x equal to alpha we get r as the remainder, then we need to subtract this r value to get the answer. Why? Because let's consider in this example, if I subtract 15 the r value remainder, what will happen? Now I put 15 in this new polynomial. When I subtract 15, this becomes a new polynomial, right? So if I put x equal to 15, you get this value evaluates to 15. We have calculated it earlier. Or you can simply substitute x equal to 15. And if you subtract 15, then we'll get f of 15 as 0, right? Because this value evaluates to 15 and you subtract 15. So f of 15 becomes 0. This new f is this. So this is the required polynomial and we need to subtract 15. So two types of question can be asked: what needs to be added or subtracted. So if what needs to be added is minus 15, and if it's asked what needs to be subtracted, then plus 15. बस साइन का कन्वेंशन ध्यान रखना, अगर सब्ट्रैक्ट कर रहे हैं तो माइनस 15 सब्ट्रैक्ट कर रहे हैं, अगर ऐड कर रहे हैं तो यहाँ प्लस लगा के एक और ये ब्रैकेट लग जाएगा -15 ऐड कर रहे हैं या 15 सब्ट्रैक्ट कर रहे हैं, and f of 15 is 0, and this is the new polynomial if they ask the new polynomial. So let's move to the next question. Before moving to the next question, this question is very important. This can be asked in boards and it has been asked many times in board. This is a particular type category question, right? So the third question is, if the polynomial this is divisible by the polynomial this, then calculate AB. This is one of questions of R.D. Sharma, a good question. So right, we see, move to its solution. Gx I have written here, fx I have written here because we are dividing this polynomial by this, right? So I'll use the division algorithm. First I'll multiply with ax, so this becomes ax cube. Then next term become minus abx square and acx on multiplying this entire with this. I've written these three terms. Then we invert the signs. Then we subtract. This gets cancelled, and I write this is x square term, so I write in the beginning. Then I subtract these x terms. This is same degree, na? We add subtract the terms with the same degree. So there's no x square coefficient here, so I write minus abx squared as it is. Then I take x common in these two. The remaining is b minus ac. and the third one is minus c is left, so minus c is written as it is. There no constant term here, so this has become my new expression. Now I will multiply with minus ab here, because then it becomes minus ab x square. Bx into minus ab becomes minus ab square x, and this multiplication becomes minus abc. Invert the signs. I've written these three terms just I told you. Adding this will get cancelled. Take x common. B minus ac plus ab square. B minus ac plus ab square. On taking x common. And this will become minus c plus abc. Right? And this remainder should be equal to 0 because it is divisible. I've told you. This polynomial is divisible by this, so remainder should be 0. 4 is divisible by 2, so remainder is 0, right? So this should be equal to 0. This is of the form a0 plus a1x. I've told you the definition of polynomials in my first video on polynomials chapter. You can refer that video if you haven't watched it, right? So this is a0, this is a1x. So this is equal to 0. This implies that a0 is also 0 and a1 is also 0. That is, the constants are 0. Suppose यहाँ पे a2 x square, a3 x cube and more terms were there. So the constant, the coefficient of every term will be 0. These a0, a1, a2, a3 will be 0, right? So equating these two 0 separately, I take minus c common. So 1 minus ab is left. So either this is 0 or this is 0. So if I equate this to 0, then I get ab equal to 1, which is my required answer. If I was asked the value of c, then I substitute ab equal to 1 here. This expression is coming from here, b minus ac plus ab square. I take ab common and substitute the value of ab as 1. I have written ab square as ab into b. This value becomes 1. Then b minus ac plus b becomes 2b. ac goes to the other side. Then I multiply with a both sides. So it becomes 2ab is equal to a square c. 2ab value is 1. So 2 is equal to a square c, or c is 2 by a square. Okay. So next question, question 4. If fx is a polynomial such that f of a multiply f of b is less than 0, then what is the number of zeros lying between a and b? So what this question is saying, that fx is a polynomial, a and b are 2 points, and value of polynomial at f of a and f of b, their multiplication is a negative number. So what is the number of zeros lying between a and b? So first concept is that product of two numbers is less than 0 only when either the first number is positive and second is negative, or the first is negative and second is positive. So if f of a and f of b are less than 0, f of a and f of b are also numbers. So f of a into f of b is less than 0 means f of a is greater than 0 and f of b is less than 0, case 1. If you can't understand, I'll give you an example. Suppose f of a is 2 and 2 is greater than 0, and f of b is minus 3. Minus 3 is less than 0. Their product will be minus 6. Minus 6 is less than 0. In the other case, f of b is 2, f of a is minus 3. Means one of them should be negative and other one should be positive. Then only the product will be negative. So I've drawn this graph. This is the x-axis, this is the y-axis, this is point x equal to a, this is point x equal to b. F of a is greater than 0, so above x-axis. F of b is less than 0, so below x-axis. So I need to join a line between these. So it will definitely cut somewhere at least once on the x-axis. Not necessarily on the left side of y-axis. It can cut here also. You can draw a line like this. Just I mean to say, it will definitely cut at least once. Similarly, in this case, f of a is less than 0 and f of b is greater than 0. You have to join these points by some way. So it will definitely cut once, the x-axis. So there will be at least one zero. What I mean is that there can be more than one zeros also. In this case, suppose f of a is less than 0, f of b is greater than 0. So graph can be like this also, no? There are multiple zeros in this case. It is cut. Is what is 0? The point where the graph cuts x-axis. So there is possibility of multiple zeros also. So what we can comment is that there is at least one zero, and there can be many zeros also depending on the polynomial, right? So this was a nice and interesting question, but a very easy question, right? So this can be asked in your MCQ or some short question, and the knowledge of graphs is important in this question, right? We move to the next question. This is the very easy question. In this question, it's given that if a fourth degree polynomial means a biquadratic polynomial is divided by a quadratic polynomial, then write the degree of the remainder. So generally, students answer it that the degree of the remainder will be 1. But the degree of remainder can be 1, or the degree of remainder can be 0 as well. This is the correct answer. So I'll explain you. As I told you, can be 1 or 0 degree. So what happens is, suppose this is a quadratic polynomial, this is a biquadratic polynomial as mentioned in the question. So we'll divide this. So we'll multiply first here by x square term, right? Then only it becomes x4. So the highest degree of the quotient will be x square, right? And on solving further, and at the last step, you'll get a remainder of the form ax plus b. I mean, you will get a linear remainder. Why? Suppose you get a higher degree quadratic remainder. Suppose x square coefficient was here, then we can multiply 1 here, or some alpha or some constant number, suppose 5, and make x like it will become 5x square, right? Means x square will be cancelled. You can multiply this number with some constant number to get x square term. But if the degree is less than x squared, then you can't multiply this number with any number to get this term. So now in this case, it's possible that a is 0 or b is 0. Anything can be possible. So degree is not necessarily linear. So in some cases, you'll find that it can also be 0. Degree can be it can be a constant polynomial, right? Degree is 0. So a can be 0 also in this case, right? So this is a very simple question, a logic based. And by this we come to the end of the video. I'll be posting more videos on this polynomial chapter covering some important questions. Till then, goodbye. Thank you. Have a nice day.